So, after a huge amount of time, we're back with the chemistry, and we'll be talking about chemistry for a while now. So, our today topic will continue after our discussion on the Rutherford's atomic model, because today we're going to learn the more advanced atomic model, the more accurate atomic model. It is more accurate than Rutherford. I cannot say it's completely accurate because there are much more advanced models than this. So you can say this is the second tier model. It's like the C tier or the B tier, not the S tier ones. They are the most advanced models, and we will study that in advanced classes. But for now, let's just study a model that is very commonly referred to different concepts and mathematics, which is the Bohr atomic model. Okay, so the Bohr atomic model, it has different concepts and different postulates, and the main concept that is discussed here are the three types of thing, or I could say, first of all, it talks about the limitations of the Rutherford's atomic model as per the Maxwell's theory of electronegativity. Sorry, the Maxwell theory of electromagnetism, which says that if a electron is revolving around a particular a radius keeping the same distance, it will eventually emit energy, and due to it, it will eventually fall into the nucleus. But that doesn't happen in this real world. So Rutherford's atomic model is completely false. Not completely false, but partially false. So what does the Bohr atomic model give us? So as I said earlier, Bohr atomic model gives us three specific things, or three specific concepts. First of all, the concepts of stationary orbits. Stationary orbits, or you could say energy levels or energy shells. I love to say it energy shells. And the second concept, it discussed about the angular momentum of the electrons. So this is very important. This is the revolutionary moment where we found the angular momentum of the electrons that are revolving around the nucleus. And the third thing is, as I said earlier, due to Maxwell's electromagnetism theory, is that an electron will emit energy eventually at some point, if it wants to go in a higher shell or a lower shell. So it calculated the emitted or the absorbed energy. So if you have confusion still now, let's just make it clear much more further than this. So stationary orbit or stationary shells or principal shells, it denotes that one electron, it moves around keeping a single orbit. So let's say there are two orbits right here. So this electron will only stay in his energy shells because it has a particular energy. Let's say its energy is 5, and the requirement of this orbit is 5. So to be in this orbit, you have to have not more than 5 amount of energy, and this electron already has that 5 amount. And let's say in this orbit, in the inner orbit, you have to have a requirement energy of 3. So this electron, you see, it doesn't have the energy of 3, it has the energy of 5. So it cannot go other than his orbit only at this point. So he's keeping in this same orbit or in the same stationary orbit or the permanent orbit, it is only revolving around this particular orbit because it is not losing energy or neither it is gaining energy. So it will stay in its own energy shell or a stationary orbit. Now, as it is moving around the stationary orbit, it will have an angular momentum. Of course, it will have an angular momentum because of the centrifugal force. And what is centrifugal force? We'll learn that in the next video, but for now, let's just get the basic concepts out. And the third thing is the emitted or absorbed energy. So this is very interesting thing right here. So let me draw that figure more nicely at this time. Okay, so this is the figure now, and let's say there is an electron here and another electron is here in this first orbit. So let's say this first orbit, it is the orbit number 1 and this is the orbit number 2. So this yellow electron right here, it has a particular amount of energy to be in that orbit. Let's say it has an energy A. Let me use a different color. Let's say it has an energy of A, and let's say the pink electron here has an energy of B, which is needed for staying in this O1 orbit, and this yellow electron needs energy A to stay in this O2 orbit. Now let's say this yellow electron doesn't want to stay in this orbit. He wants to migrate. He wants to migrate at this orbit. Okay, so to migrate at this orbit, and we need to know that this orbit's energy, so the energy B will be less than the energy of A. That means A's energy is greater. So to move here, to move from a lower energy to move from a higher energy to a lower energy, it has to emit energy. Okay, so it will emit energy in the environment or into another thing. It will emit energy, so the energy will be diverging from him, so he will emit the energy. And if B wants to go, if this electron wants to go from this O1 orbit to this O2 orbit, it has to gain energy, right? Because it has less amount of energy. But if it wants to go to A, it will have to gain the energy. So these are the basic concept of the Bohr atomic model, and in the next class we will study more about the emitted energies and the angular momentum and how to find the radius of the orbits. So we will have to find the radius of this orbit, the radius of this orbit right here, and we will know about the limitations of this Bohr atomic model. So till then, stay tuned.